Hey guys, so welcome to the lesson on scatterplot, line of best fit, and linear regression. So let's get started. Okay, so this expression is x plus 4 times x plus 4. So x plus 4 times x plus 4. Remember, because it's exactly the same parentheses, you can rewrite that as x plus 4 squared. Squared. Okay. We're not going to go over that more because it's just not today's lesson. But if you have a question, that's a good one for office hours. Okay. For the definitions here, let me see, I might be in the way of it. But all right, so scatter plots are just graphs, right? So we're used to having graphs that make a specific shape. That's how we know it's linear. It makes all the points connect to make a straight line. Or a parabola, all the points connect in that very specific shape to make a U shape. But in a scatter plot, we really have more of just a point here and a point there. So I would have an X and a Y axis. And instead of a straight line, I might have a point here, a point over here, a point here, a point there, right? So not exactly straight. It's kind of scattered around, which is how it got its name. A line of best fit is also called a trend line, because just like fashion trends, like, okay, we're all wearing fanny packs today, or okay, TikTok is like a thing, right? These have a certain pattern to them, and we can kind of follow that pattern to make a prediction about a future event, right? Like I think in our last example we'll get to is like, what temperature is it, and how much money do you make if you own a coffee shop, right? So there's a certain relationship that we can predict using a function that we're more familiar with, like in this case, a line. So I just drew one, right? This red line is a line of best fit or a trend line. It goes as in the middle of those points as possible. And a linear regression, oh, excuse me, my computer is getting low on battery. A linear regression just uses our calculator to get the most accurate line that fits the scatter points as possible. So even if I do what looks to me a super good line of best fit, the calculator is always just going to be a little bit more accurate. So this is a line of best fit. It is just the most accurate as you can possibly get. And today we're really just talking about lines, about linear best fit, although there are others. Okay, so again, in this form. Okay, so let's move on to the next section. And remember that this is day 1 of 2. So you're just really trying to follow along as best you can. The strongest line of best fit matches exactly a line. All right. So the strongest one in this case would be graph 1. All right, because all of the points are exactly on that line. There's no separation between your points and that line. Whereas, let's put this in blue, your weakest one out of these 3 would be graph 3, just because the points are further away from your line of best fit compared with 2, right, which is kind of in the middle. The points aren't on the line, but it's a little closer, right? So the strongest one is on the line, and as the points are closer to your line of best fit, that's a stronger correlation. As they're further from your line of best fit, they're just all over, that's weaker. Okay. So now let's go to the next one. Okay. Here they just want you to draw a line of best fit. And so you're just going to draw a line as in the middle of these points as possible. So for this one, and it should be exactly a straight line, not like Miss Cram is doing little bumps, right? So these are both lines of best fit. Is it the most accurate? No, I'd have to use the calculator, but it's pretty close. And if I said, hey, for graph A, if I have an X value of 2, you could tell me, hey, the Y value is probably going to be around maybe 2.5. That would be exactly on the line. You could also say the Y value could be about 4, 3.5, like anywhere around this line of best fit. But what you couldn't tell me is, hey, if the X value is 2, the Y value would be -5, right? That's nowhere even near all of those scatter points. So that would be no, like you can't, no, right? But you could say, hey, Y could be 2, right? It could be 2.5, could be 3, could be 4, right? Anywhere around this line of best fit. The line itself, let's just do that quickly. And again, this is an approximate, right? But I look, the y-intercept is about 1, okay? And then it looks like I go up 1 and over about 1.5, right? 1, all right? So I could say the slope is up 1 and over about 1.5. Again, super accurate? No, we need the calculator for that. For graph B, my line of best fit that I drew, the y-intercept is about at 0.5 on the negative side. Okay, and then it looks like it goes about down, let's say down 1/2 and over 1/2. Okay, so a half divided by itself, a half would be about 1x. But don't forget that this is going down, right? Down 1/2 over 1/2. So that would be negative. All right. So again, both linear equations, they're approximately, right, line of best fit, matching up with those points. Okay. So now the last one is really an exploration. And this story is talking about temperature. So like how hot is it? And comparing those temperatures to coffee sales, right? So do coffee sales go up or go down when the temperature, like if it's a blizzard, maybe people are getting more coffee, right? Maybe when it's colder, they get more coffee. Maybe when it's hotter, it gets more iced coffee. So maybe different extreme temperatures are higher sales versus like, just a regular like 60, 70 degree day. So we're just trying to compare those two things and see, is there a relationship between those? So here's the data. You need to create a scatter plot. So you're not using X and Y, you're using T and F of T. And what we're going to do right now is use the calculator to find the linear regression function. And again, this is not just the line of best fit. It is that, but it's the most accurate. So I'm not just guesstimating here. So what I'm going to do is I'm going to go to the calculator. If you do not have a calculator, where is my calculator? I had it. That is not my calculator. Uh-oh. Where did my calculator go? All right. Okay, sorry guys. I paused it to find my calculator. I found it. I just went on the Texas Instruments website and downloaded this for free now. So make sure that you have some kind of graphing calculator. So I don't have enough space to have the calculator and the data, but I'm going to be putting in this data here into my graphing calculator. All right. So here we go. I'm going to go back to stat. So the first steps are very similar to standard deviation. So this button, stat, and I'm going to edit. Now, I've already put in all of the data terms. Remember, if you need to clear it, go all the way up to L2 or L1, whatever list you're clearing, and hit clear followed by enter. Okay, so I put all of this data in. These are all of the temperatures, the high temperatures. And for the list 2, I put the Y values in, or the F of T values, which were the coffee sales. So the money, the amount of money sold. All right, so once you have list 1 and list 2 in your stat edit, you've edited those lists, go back to stat, and we're going to go to calc. So remember, last time we did this, we did one variable stat because we were looking at standard deviation just on one thing. Like mostly it was test scores, right? Just one set of test scores. Now we have coffee sales, our Y value, and the high temperatures. So we have two things, and we want the linear regression. So for where it says lin regress, right? And you see there's quadratic, there's other types of regression models, but we are only focusing on linear regression. Okay, we're gonna press enter, 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 right? These are list 1 and list 2 that we input. Calculate, enter. And here is our linear regression equation. So instead of A, right, instead of A, we're going to replace this A with this, right? And the same for B. Instead of B, we're going to replace B with whatever value they give. Okay. So now we need to see, are we rounding it to the nearest decimal? Are we like, what are we doing here? All right, and so I'm going to make this smaller. And it says to put it in to the nearest integer. Sorry, I've got so many things going on here. All right, so if you notice, it's got, hey, I want it to the nearest integer right here. Okay, so nearest integer. All right, and wait, come back, calculator. All right, so here I'm going to put not Y, because they give me a value for Y. So I'm going to put Y. Oops, wait, I said not Y. F of T, F of T equals, and instead of A, remember I'm putting in this value. So I want it to be the nearest integer, which is the nearest whole number. So I'd say negative 58. Remember, it would go to 59 if the next number was a 5 or above, but it's only a 2. So negative 58 at, oh, wait, I don't put X. Remember, I put T. All right, so negative 58T, and they do take a point off of this on like a Regents exam or a state exam. So 6182. So 6, 8, 1. And does it stay a 2? Yeah, I look at the next digit after the 2, and it's not a 5 or above, so it stays there. So this right here is my linear regression, right? So this is the most accurate line of best fit that the calculator can give you. Okay, so now I'm going to clear that. Make sure you pause me if you need. And we're going to go to the last slide, which is just, I created a, let's move me a little bit here if we can. Maybe not. Who knows? Okay, so over here I have coffee sales, F of T, and here high temperature T. I'm not going to do all of the points for sake of time, but I did want to show you just a couple of them. Oh, wait, share. Okay. All right. So if the high temperature is 54, the coffee sales were 2,900. So 54 is about here, and this is 2,000. And this, so 2,900 is just below 3,000, right? So point would go there. Then I have 50, and it goes a little over 3,000. So temperature, high temperature is 50, it goes a little over 3,000. So you can do all of those points on your own. Just make sure you labeled your axes appropriately. And the other thing is, if you notice, I go by fives on the temperature axis. So 45, 50, 55, 60, evenly spaced. But from 0 to 45, that's not 5, right? That doesn't match with the even spacing. So that's why I did a little break here. All right. That just shows, hey, this isn't part of that even spacing. It's a little bit longer. And same thing on the y-axis, right? To go from 0 to 2,000, right? Then I go 2,500, 3,000, 3,500, 4,000. So here I've got even spacing, but between 0 and 2,000, not even spacing. So put that little break. Alrighty, so that is it. You guys know what to do for questions, comments, or concerns. And as I get to the last slide, please do your exit ticket questions. 10